Okay, so we're doing polar coordinates today. So we know what rectangular coordinates are. That's just like your regular x, y ordered pairs that you graph. Yeah? So now we're talking about polar coordinates. So that's basically taking like your unit circle and putting it on top of your regular like rectangular graph and then plotting points that way. So those coordinates are going to be written as r theta. So r is your radius, your distance from the center, and theta is just some angle measure. So that's a big old paragraph talking about what that is. There's some vocabulary here, so I mean you can read that, but I think it's just easy to go ahead and do it, so we just go ahead and do it. Okay, cool. So you've got a bunch of polar coordinates here. So again, the first part is your r, is your radius, and then the second part is your angle measure. So when you go to plot those, if we're talking about the point right here, so we've got 3 and then 5 pi over 3. So you go out to the radius of 3, and then we need to find that angle measure of 5 pi over 3. So the one that I've given you is in degrees, but what is 5 pi over 3 in radians? Or if we like converted that from radians to degrees, where would that fall? 300. So you would take at 3, because that's your radius, we'll go all the way around to where 300 is. So that's right here. And that's where that point would fall. Does that make any sense? And so I'm going to label it A so you know where that happens. Do you have questions on that? So that's basically all it is. You just go to your radius and then work your way around the circle. So then for the next one, our radius is 2. Our angle measure is negative pi over 4. So again, that's like in radians as degrees. What is pi over 4? 45. So it'd be the same thing as negative 45. So when your angle is negative, do you remember how you handle that? What do? You just go the opposite direction. So our radius is 2, and we're going to go back 45 degrees. So that's going to be right there. I'm going to label that B because that's where that one came from. Is that all right? So again, we wrote that radius of 2, and then we just went back 45 degrees. Or negative pi over 4. For point C, it's at 3, 0. So your radius is 3 and your angle measure is 0, so don't go anywhere. It's just going to stay right there. That would be C. For D, our radius is negative now. So how do you think we might handle that? Go left, exactly. So we're going to go left 2, and then we're still going around pi over 4 or 45 degrees. So that is going to put us right about here. And I'm going to label that D. Is that okay? Question? So then the next one for E, we're at 3, then 90. So your radius is 3 and you're going around 90 degrees. So that's going to fall right there. For F, we've got 4, 270. So your radius is all the way out at 4. And then we're going around 270 degrees. And that's down here. Then for G, we've got negative 3 and then 120. So begin with that negative radius. You're going to go left instead of right. And then we're going 120 degrees around. So that's going to be right here. So that's where we had point A earlier. It's the same thing. I'm sorry? Okay. So again, that's where we had point A earlier. So what you're going to find is that you can write your coordinates here multiple ways. So just like with your unit circle, you know how we can keep going around and around and around and we'll still land at like the same angle. So the same ideas apply here. So even though the coordinate is written differently than it was up here, it still lands in the same place. Then last one we got is H, so that's negative 2 and then 135. So again, with that negative radius, you'll go left first, and then 135 around is going to put us at B, I believe. Yeah. So again, the same point we had for B. I'm just going to label it H as well. Questions? Okay. So this next section is just talking about how you can write those points in different ways. So if your coordinate is like r theta, then you could have negative r and then theta plus pi, and it's going to give you the same point, which is kind of what we were playing with A and G and B and H up there. So the angles theta plus 2n pi, where n is any integer, all have the same terminal sides as theta. So do y'all remember back when we were solving equations, trig equations, and we got our answer for whatever angle, and you had to say plus 2k pi? That's that same idea coming back again. Okay, so that's all that's telling you, and we're going to move on to that. So what we're going to do for these, it wants us to graph the polar coordinate and the two other representations for r is greater than 0 and r is less than 0. So plot point P with polar coordinates 3 pi over 6 and find other polar coordinates for r theta for the same point. So we are gonna do, we'll plot the point first. So if we're looking at like our graph here, we'd have like an angle, and how do I draw this? Our point 3 pi over 6 is gonna be like here, yeah? So it's saying for us to get another point, our radius is still going to be positive, so your radius is still going to be 3, okay? But our angle measure needs to be between 2 pi and 4 pi. So if it's between 2 pi and 4 pi, that means you've already gone around the unit circle once, and then we still need to land in the same place. So we're going around the circle and a little bit more to land back at that same angle. Does that make any sense? So how would we find the angle measure that we need? So our angle that we need to land at pi over 6. Exactly, just add 2 pi to that. So we'll have 2 pi plus pi over 6. So that's like 12 pi over 6 plus pi over 6. What's that going to give you? 13 pi over 6. So again, our radius stayed the same. It was just 3. And then your angle measure changed to 13 pi over 6. So it's like a different coordinate, but it's still going to land us in the same place. Is that okay? Questions? Right, so looking at the next part. This time we want to rewrite this coordinate with a negative radius. So we'll have like negative 3 for our radius instead. So let's sketch that angle, or so we know what we're talking about here a little bit. So we know that our point that we want is up here, but we're starting with the negative radius, so we've got to go all the way around to get there. So how would we find the angle measure that we need this time? Add pi, right? Because you're going halfway around and then whatever angle you need. So we would have like pi plus pi over 6. So what is pi plus pi over 6? 7 pi over 6. And we said our radius was just going to be negative 3 this time. And your angle measure is 7 pi over 6. So again, different coordinate, but still lands you in the same place. Is that okay? Questions? So for the last one, we've got a positive radius, so your radius is still going to be what? 3. Nothing's going to change there. But we want a negative angle this time. So we know that we still want to land right here. But instead of going this way around, we're going to have to go around this way and land in that angle. So how could we figure out what angle measure we need? Two pi minus whatever we started with. Does that make sense? Or you could do it technically, I guess you could say your angle minus 2 pi, because that would give you a negative answer. So we'll do it that way. So we started at pi over 6, we're going backwards, so subtract 2 pi from that. And what do we end up getting? Negative 11 pi over 6. So again, different coordinate, lands you in the same place. Questions on any of that? Questions? We're good. Okay. So that's basically it there. The next section is converting your polar coordinates and your rectangular coordinates, so you need to be able to convert from polar to rectangular and rectangular to polar. This is a big long explanation of how you get all that, but basically these are the formulas that you need to know. So I would highlight, underline, circle something for those. So if you're going from polar to rectangular, to get your x value, you're going to do r times cosine of theta. To get your y value, you're going to do r times sine of theta. If you're going from rectangular to polar coordinates, to get your r value, you're going to use r squared equals x squared plus y squared. So that's like Pythagorean theorem because we're talking about this triangle. And then to get your angle measure, you'll just do inverse tangent of y over x. So that's all you need to memorize here. But the more you use them, like, you'll memorize them without even trying, so it's not too bad. So we are going to convert both of these from polar to rectangular. So if you're going from polar to rectangular, you're using these two coordinates up here. So to find our x value, you're going to do r times cosine of your angle. So our r was 6, and then our angle was pi over 6, so we're doing 6 times pi over 6. Just use your unit circle, because we want exact answers. So again, if you don't have that out, you might want to get it out. What is cosine of pi over 6? Root 3 over 2, so you've got 6 times root 3 over 2. And so that's just 3 root 3. Okay? 6 divided by 2 is 3. So 3 times the square root of 3. Yeah, no, maybe. So then to find your y value, we're going to use r times sine of theta. So our r is still 6, your theta is pi over 6, so sine of pi over 6. And what is sine of pi over 6? So 6 times 1/2, what's half of 6? So y equals 3. So when we go write our coordinate, it's going to be 3 root 3, comma 3. Questions there? Alright. So that's that one. Then for number 2, we're doing the exact same thing. We're going to switch that from polar coordinates to rectangular coordinates. So you're using the same formulas again. So to find your x value, we're going to do your radius, so -4 times cosine of your angle, so cosine of negative pi over 4. So what is cosine of negative pi over 4? Square root 2 over 2, so we've got -4 times square root 2 over 2. So -4 divided by 2 is -2, so that whole thing's just -2 root 2. Then to find your y coordinate, we're going to use radius times sine of theta, so -4 times sine of negative pi over 4. And what is sine of negative pi over 4? Negative root 2 over 2. So that's going to be positive 2 root 2 this time. So when we go to write our coordinates, -2 root 2, and then 2 root 2 here. So you can kind of double check yourself to make sure that you're doing things properly. Whatever coordinate you had, if you can tell what quadrant that falls in, once you convert it, it should still fall in that quadrant. So this is going to be more of a big deal when we go from rectangular to polar coordinates. But like we could check this one. So your radius is 6, your angle measure is pi over 6. Your angle is just pi over 6. What quadrant does that fall in? Quadrant 1. So this point, rectangular point, you've got positive, positive. Is that quadrant 1 as well? Yes, so you're probably good to go there. And then for this next one, our radius was -4, and your angle measure was also negative. So when you think about that one, like we went backwards 4, and then instead of going around your angle measure, we took it back this way. So that landed us in quadrant 2. Yeah? And then when we converted it, we were negative positive. So is that also quadrant 2? Yes. Does that make sense? So that's like a quick way to like check that you're good there. But like I said, when you're converting from rectangular to polar, it's going to be more of a big deal there. And you'll see that in just a second. So we're going to switch this one from rectangular to polar coordinates. So you're using these two formulas now. So to get our r value, we're going to have r squared equals x squared plus y squared. So negative 1 squared plus negative root 3 squared. So negative 1 squared is going to give us 1. Negative root 3 squared is just 3. And 1 plus 3 gives you what? 1 plus 3 gives you what? 4. And the square root of 4 is 2. So your radius is 2. Is that okay? And we're always going to go with the positive there. Okay. Then to find our angle measure, we're going to do tangent of y over x. So tangent theta equals negative root 3 over negative 1. So we're really just doing inverse tangent of square root 3. So where does tangent equal square root 3? At pi over 3. So our theta would be pi over 3. So let's check that real quick. This point, negative 1, negative 3. Is that correct? What quadrant is that going to fall in? Third quadrant, right? Does this point, if we have a radius of 2 and an angle measure of pi over 3, fall in quadrant 3?
No.
So what's an equivalent angle that we could have that's in quadrant 3? Do y'all kind of get what I'm saying? Or no? So we said that pi over 3 would work right here, right? Because it was 1/2 negative root 3 here. So we need that in quadrant 3. That's going to be 4 pi over 3. Does that make sense? So instead of using pi over 3, let's use 4 pi over 3. Because we've got to fall in the same quadrant. So then our converted coordinate there is going to be 2 and then 4 pi over 3. So especially when you're converting from rectangular to polar coordinates, you've got to check those quadrants to make sure that it's falling in the same place for both of them. Questions on that? I don't know what they're doing next door. It's insane. What's math 1? That's what the rest of my day is like. Are y'all feeling overwhelmed right now, or are you ready to try a little bit more?
A little overwhelmed.
A little overwhelmed? Okay, so we're going to pause right here. We'll do 4 and 5 tomorrow. I'm going to give you the homework, and you're going to only do through 10. Does that make sense?
2 through 10?
Through 10. 1 through 10.
What are you going to eat?
You're just copying at 10. We'll do the rest of the stuff tomorrow. And we're just going to practice this all day tomorrow. So I'll show you how we're going to do stuff. I haven't started the video. Awesome.